Hey guys, it's Monday. I know, I'm not here. I'm sorry. I'm at a yearbook conference trying to, a yearbook workshop with some other yearbook advisors, and we're trying to get some work done on the yearbook because we have a deadline this week. So, hopefully you guys are doing okay and you had a good weekend. I wanted to let you know you should have gotten your new builder. We'll grade your builder from last week tomorrow. And then at the end of this, you do not have a homework section over this, but you will, there's not a separate homework page over this, but you will have notes for tonight that you need to get from the sub as well. So, yeah. Anyways, you'll have a video tonight as well. But this is the video for class today. So, I want you to look here. We're going to be working with polynomials again. We're going to simplify the following expressions, indicate if it's a non-monomial solution. I'll explain that as we go. But we just first want to start with example number 1. So these are polynomials. We're multiplying two sets of numbers. So this first one, remember, we're going to multiply them like regular. You guys know how to do this. This is just a review from last unit. We have the numbers follow regular rules. Let me zoom in here. The numbers follow regular rules. So we have a 2 and a 4. That's going to give us an 8. And then remember your exponent rules. When you multiply an exponent and an exponent, remember you have to add that little 1. You add your exponents. So you have an a squared and an a to the 1. That's going to give you a to the 3rd. And then a b1 and a b2 gives you a b to the 3rd. That's all we do for number 1. That's just a review. Okay. Look at number 2. You should know how to do this as well. But here on this one we have this second term here is a power to a power. So we're going to work that one out first. Negative 5 times negative 5. Because you got to do negative 5 squared. Everything in here is squared. Negative 5 times negative 5 is 25. Positive 25. And then we have a C1 to the second power. A power to power, we multiply. So that's going to be C to the second, D to the 8th. That's our new set here. And now we're going to multiply this first set times the second set. Again, this should be just a review from what we did last unit with the exponents. 3 times 25 is a 75. C, we're going to add, we're multiplying our exponents now. It's not a power to power. We're just going to add them together. C to the 4th, D to the 10th. Okay? Hopefully this is still a review for you. Alright. So we have everything in here in the parentheses to the 5th power. So negative 3 to the 5th. Okay, so I'm going to do that in my calculator. Negative 243. So we have negative 243. Alright, so power to power means we multiply. 3 times 5 is 15, x to the 15. 1 times 5 is 5. And 6 times 5 is 30. So this is our answer. Ooh, number 4 is easy. Please look at it and tell us all together at once what the answer is. You got it. It's 1. Okay, now look at number 5. This one's a little different because it's not a polynomial. We're not multiplying anything times anything. And it's also a negative exponent. So what do we do when we have a negative exponent? We put everything under a 1. So we keep that negative exponent inside the parentheses for now. We're not going to keep it there for long. We wanted to make this 2 a positive 2 first. And we're going to solve inside of that first. So we're going to say 1 over. Alright, so now we're going to solve this bottom out. Negative 11 times negative 11. That gives us a 121. 11 times 11 is 121, positive. And then we have a negative 3 to the second power. So that's power to power. We're going to multiply x to the negative 6. And then 1 times 2, y to the second. So why can't we leave this answer like it is? Do you see this negative 6 right here? He is not very nice. He cannot stay negative. So we're going to have to make him positive. The same way we make things positive when they're on the top, we send them to the bottom. We send the bottom to the top to make them positive. So we end up with x to the 6 at the top with our 1, but we don't have to have that 1 there anymore because it's understood. 121 y to the second is on the bottom, and that's how we're going to keep it. We can't subtract because this is an x and a y. They're not the same. Alright. Woo, look at number 6. Number 6, we do not have room to do that right there. So what I want you to do is, if you have some room on the side, which I have some on the bottom down here, I'm going to rewrite that on the bottom. Number 6. I'm just rewriting the problem to give ourselves some more room. Okay. Alright, so this one looks tricky. We're just going to break it down part by part, and it'll be fine. So we're going to simplify this guy first on top. This thing. Okay, so we have to ask ourselves, or we tell ourselves, not ask ourselves, everything inside this parentheses is to the third power. So that 4 goes to the third power. 4 times 4 times 4 is 64. Then we're going to go to our x's. X to the second to the third power. We're going to multiply those because it's power to power. Y to the third is y to the ninth. 3 times 3. 4 times z would be 12. Z to the 12. Okay? Then, so now we're done with this. Kind of scratch that out. We're going to multiply that times this negative 3xy. So we're going to say 64 times negative 3 . You know what, though, first let's clean up the bottom first. Let's clean up all the stuff that's power to power first. Let's not do that yet. Okay, let's do the bottom. So we have everything inside here is to the second power. So negative 2 to the second power will give us a positive 4. X 1 to the second power gives us just x squared. Y2 to the second power gives us y to the second power would give us a y4, power to power, and z would become z6. Okay, so now we're left with, this is what we have all simplified. Now we're going to multiply this times this on the top. 64 times negative 3. 64 times negative 3. Numbers follow the regular number rules. That's going to give us, if we do that on the calculator, negative 192. Negative 192. Okay. So then we have a 1 and a 1 here. So we're just multiplying. So we're going to add these exponents. We have a x6 and x1 gives us x7. A y9 and a y1 gives us a y10. And then there's no other z, so it stays z12. Okay? we're going to go to the bottom now and rewrite what we have. Okay, now what do we do when we have division? We subtract. Okay, so a negative 192 divided by 4, do that on the calculator, it's going to give us a negative 48. Okay, and 7 minus 2, we're going to subtract those, remember we're dividing, is going to give us a 5, x to the 5. 10 minus 4, y to the 6th. 12 minus 6, z to the 6th. Alright, we just solved that monster problem at number 6. It is negative 48, x to the 5th, y to the 6th, z to the 6th. Look at that. Woo! Nice. So this is just review, right? We're reviewing all of our exponent rules, making sure we are really touched up on those. So let's look at this table here. Okay, we are comparing polynomials. We're going to tell what type of polynomial it is and how many numbers of terms are in it. So this is just a monomial, alright, because there's only one number and it's one term and it doesn't have any variables, so it's what we call constant, if you remember from the other day. Then we have this one is not a polynomial because there is division happening here. And remember, you can't divide in polynomials. So this is not a polynomial. It's not. Okay? Because we cannot have a denominator. We can't have division. Okay. So look at this next one, number 9. We have two terms that's binomial. Sorry, I have kind of a cold. That's two terms that we're adding or subtracting. This is also two terms, binomial, 1, 2. This one is 1, 2, 3. What do we call that? A trinomial. And down here we have 1, 2, 3, also trinomial. Okay? Alright, so let's see if we can take it one step further today. Combine the polynomials as indicated. So if you remember the rules from the other day, we said combine like terms within the parentheses first, distribute if necessary, and then combine the remaining like terms. So I'm going to write that on the side here. Step 1, combine like terms within parentheses. Okay? Step 2, distribute if you can. Step 3, combine other like terms. Okay. If you need to pause this at any time, feel free, please. So, let's follow those steps here. Can we combine any like terms in this parentheses? No, they're all different. We have an x squared, an x, and an irregular constant number. Same over here. So we're going to, do we need to distribute anything? Nope. This is like what we did on Friday. So, combine other like terms. Well, this is adding. 5x squared and a 3x squared gives us an 8x squared. A 3x and a negative 1x gives us a 2x. And a negative 4 and a positive 2 gives us a negative 2. So that's our answer here. Okay, no like terms inside the parentheses here. Again, we're adding 2e squared and a negative 3e squared. Make sure you see that those are flipped over there. That's going to give us a negative 1e squared, or a negative e squared. And then a negative 5e and a positive plus a 7e is going to give us a 2e positive. So there's your answer. Let's look here at 15. No like terms inside the parentheses. So we're going to combine what we have. But remember, this is subtraction. So we're going to flip all of these signs. So this 4y becomes a negative. It's going to change to add, and then negative 4y, negative 3y, and plus 5. Because of that minus sign changes all the signs on the inside of that second term. So we have a 2y squared and a negative 4y squared. Negative 2y squared. A 4y and a negative 3y will give us just a y, or a 1y. And then we have a negative 8 and a positive 5 is a negative 3. Now, I want you to try to do number 16 on your own. Pause it for a few minutes as a class. Then check it with mine. Okay? So d squared, there's no other d squared, so that's all it is. A negative 1d and a plus a negative 2d is going to give us a negative 3d. And then we have a positive 5 and a negative 5. It just cancels out, and we're left with just this, a d squared minus 3d. Okay? Alright, so at this time, you're going to get your notes for tonight's lesson. And you're going to put those into your journal, and then when you get home, you can watch tonight's lesson. We're going to start multiplying polynomials. I'm going to teach you a new method called FOIL. FOIL. We're going to be foiling, and then I'll see you tomorrow. So do the next lesson tonight. Watch it tonight, and I'll see you tomorrow. Alright? Have a good day.